Hello again. All right, we're gonna move right along. Let's get this ball rolling. I don't know where I'm at today. It's kind of hot here, and I had to cross this little river called the River Styx. And there was this kind of red guy with a long tail and holding some kind of pitchfork. But I don't know what he was doing here, but seemed like a nice enough fellow. I decided to saunter on in. So here I am, but it's kind of hot. So let's get this ball rolling here. This is chapter 8, chemical properties. Now, again, these PowerPoints videos is really not the whole meat and potatoes of everything. You need to read these chapters in the book, and it's very interesting and it didn't cost you anything. So there you go. So chapter 8, maybe fully realized hazmat resources like the ERG. What's the ERG? Emergency Response Guide. We must first categorize the hazards. There are many ways to do this, but there are a lot of terms we use to categorize and identify hazards. Oops, going backwards again. Let's go over some terminology to help in classifying chemicals and identify the hazards. Lower explosive limit, LEL, also called the lower flammability limit, LFL, the minimum concentration of vapors in the air that will burn if ignited. The upper flammability limit, UFL, or maybe that's the Universal Football League. No, I think it's the upper flammability limit. The maximum concentration of vapors in the air that will burn if ignited. So you got these two together, you get a flammable range, the area between the LEL and the UEL. It's the perfect concentration for fire and explosions to occur. So there you go. There's 0. There's your LEL, your lower explosive limit. So in other words, anything to the left of that would be too lean to burn. Upper explosive limit, anything to the right of that or above that, in this particular instance, 7.6% would be too rich to burn. So your flammable range in this instance is 1.4% to 7.6%. So there's a few abbreviations you're going to see. ppm, parts per million. That's pretty familiar with that. ppb, parts per billion, used to measure concentrations of vapor in the atmosphere. Parts per million doesn't sound like much, but what would equal 1%? So what's 1% of a million? 10,000. So 1 parts per million, 10,000 parts per million, excuse me, is 1%. So part per million is not very much. But sometimes 3 or 4 parts per million can be deadly. So in some instances, so it may look like much, but it can be. IDLH, immediately dangerous to life and health. IDLH atmospheres can cause immediate death. That's why it's called immediately dangerous to life and health. Oxygen deficiency, high toxicity are examples of IDLH. And I like mnemonics, and there's a good one on this one. I don't live here, IDLH. That's how I can remember what IDLH is, or how I can remember what that abbreviation. I don't live here. Physical states of matter or chemicals are solid, liquid, or gas. Odor and appearance. Some chemicals have specific odor or appearance. A green vapor cloud is an indication of chlorine, and that's something you don't want to mess with. Chlorine is bad stuff. Bitter almonds is hydrogen cyanide. I don't know where they come up with this. I like almonds, I eat almonds, but I've never don't know what an almond smells like, let alone a bitter almond. But I guess if I was in hydrogen cyanide, I would. Not for long, though. Rotten eggs, we all kind of know what those smell like. That's hydrogen sulfide. Anhydrous ammonia has a distinct smell. We call that self-alarming because it's going to let you know that it's there. It's kind of a good thing. Believe, boiling liquid expanding vapor explosion. When tanks or cylinders are exposed to heat and the vapor expands past the pressure rating of a container. Not to be confused with oblivic, which is commonly called 5 pounds of horse manure in a 4-pound bag. That's oblivic. But a believe is a really a real term used in hazmat. Boiling liquid expanding vapor explosion. There's a video on it. It's pretty interesting. So this is talking about now the oxygen concentrations. If you look at the bottom, 0 to 5% rapid unconsciousness and death. There's basically no oxygen, 0 to 5%. So you're going to die pretty quick. About 5%, you're going to be unconscious and death within a minute. 7% nausea, fatigue, unconsciousness within a minute. And of course, you'll die in a little bit. 10% extreme weakness, lethargic, headache, dizziness very quickly. 15% lethargic, nausea, headaches within minutes. Even at 18%, you're going to be dizziness, weakness, within a few minutes. You're going to be alive for a while at 18%, maybe 15, but you're going to know it. Or the problem is you're going to feel it. You might not know it. That's the problem with it. There's nothing that tells you that except how you feel. And you may just feel it's other factors involved. But, so if you start feeling something like this, you ought to consider it could be an oxygen concentration. The normal atmosphere is about 21%, 20.8%. It's how these things go. They vary a little bit in the normal atmosphere. 19.5 to 23 is okay. And you get 23% up, increased flammability. Doesn't mean it's just going to burst into flame when it's 23%. But if there is a fire, it's going to make it a lot worse. This is a pH chart. pH is, we'll talk about what the pH means in a minute. The higher you go, it's more acidic it is. Battery acid, is lower. The lower it goes, the more acidic it is. 0. This is kind of backwards, but battery acid, sulfuric acid, the one. Lemon juice or vinegar is all the way down to a 2. So it's pretty acidic. Then orange soda, orange juice, 3. Acid rain, 4.2, 4.4. Acid lake, 4.5. pH around 5 by bananas. Clean rains of 5.6. A healthy lake, 6.5. Milk is about 6.5, 6.8. Pure water, pH of 7. This is a really odd measurement standard of 7 being neutral, and that's water. And then on each side of 7 being acidic or basic. But it's been around for a long time, well accepted. You should know what it is. pH of 8, seawater or eggs. pH of 9, baking soda. pH 10, milk and magnesia. pH of 11 is ammonia. pH of 12 is soapy water. Bleach is 13, and liquid drain cleaner is 14. You don't want to be on either end of this. The closer you are to the middle, the better off. The safer you're going to be. pH is percent hydrogen ions. Measurement of the corrosivity of chemicals. Acidic and caustic or base. Caustic, basic, or basic is the same thing. Each level is severity of 10. Boiling point is the temperature at which the chemical's vapor pressure is equal to the atmospheric pressure, allowing the chemical to go from a liquid to a gas. Flash point is the minimum temperature at which a vapor of a liquid or solid material can ignite if exposed to an ignition source, but does not give enough vapors to sustain combustion. So flash point is getting close to the burning point, but it's going to just flash. It's not going to sustain combustion. Other ignition temperature is the minimum temperature required to initiate or cause self-sustained combustion of a solid, liquid, or gas, independently of the heating of heated element. Spontaneously combustible materials is self-heating or pyrophoric material due to an exothermic reaction with air. Deflagrations, combustion that occurs at less than 1,086 feet per second, which creates a shock wave moving at less than 3,300 feet per second. And the next step up from a deflagration is a detonation. It's a combustion. So detonation is just really a fast combustion that occurs at greater than 1,086 feet per second, which creates a shock wave moving at greater than 3,300 feet per second. So 3,300 feet per second, that's over half a mile per second per shock wave. Implosions, when a container is rapidly cooled to decrease pressure and a negative pressure results inside the container, creating a vacuum. That could just be cool, but you could, in South Carolina, there was a competitor that set up shop there from China, I think, and they set up 2 of these big silos to store their pellets of polyester fiber, like polyester fiber out of. And the pellets are kind of like a little bigger than rice, and they store them in big silos. Well, they set up these silos. They didn't vent it properly, so when they pulled out the stuff at the bottom of the silo, and it decreased the pressure inside, and then it imploded. It just caved in, and it was by the road. Everybody could see it, and everybody, of course, the competing companies, as they drove by, kind of chuckled at them. They were in this business. They didn't know what they were doing, but. Vapor density, the weight of a chemical in air. Air is equal to 1. So the gas or vapors, methane is 0.55, carbon monoxide 0.97. So you see carbon monoxide pretty close to air. Hydrogen sulfide, a little heavier than air. Petrol vapor, 3. So that's heavier, a lot heavier than air. So melting and freezing point. Melting point is the temperature at which a chemical goes from a solid to a liquid. Freezing point is the temperature at which the chemical goes from a liquid to a solid. Vapor pressure is the pressure exerted by a vapor on the sides of an exposed container. It is essentially the pressure of the material as it boils or off gases within a container, and that's measured in millimeters of mercury. Specific gravity, that's a pretty common term. The weight of a solid or liquid compared to water. Water has a value equal to 1. Chemical with a specific gravity less than 1 will float, greater than 1 will sink. There's a nice video in this I don't know if it's this chapter or not about specific gravity. When you watch it, it'll give you a lot more information than this. VOCs, volatile organic compounds. Organic chemical compounds whose composition makes it possible for them to evaporate under normal indoor atmospheric conditions of temperature and pressure. Examples include propane, butane, acetone, toluene, to name a few. Viscosity is measured the thickness of liquids or how easy they flow. A low viscosity liquid will flow like water. A high viscosity liquid will flow like honey. Lower viscosity, more likely to spread and contaminate more area at a higher rate. I don't know if you guys, girls out there, know what about motor oil used to be. You used to get like a lower viscosity motor oil in the summertime, in the wintertime when it was cooler, and you want something to flow better. In the wintertime, you want something higher viscosity. And then they came up with these viscosities of 10 to 50, and that's what they use now. I don't think they even have the different things. They used to have to use a different motor oil in different weather because of the different viscosity of it. Solubility, the ability of a material to mix uniformly with another to make a solution. Chemicals that are soluble in water will mix readily with water, making a water chemical solution. Now, in this particular instance, solution is not the answer, just a mixture. Okay, actually, it's not technically, it's not a mixture either. That's a solution is, again, mixing two chemicals they make a solution. The material present in the greater amount is called the solvent, while the lesser amount of material, usually the additive, is called the solute. So that's what a solution is all about, and that's solubility. Sublimation, the ability of a material to go from the solid phase to the gas phase without appearing to have gone through the liquid phase. Dry ice is a perfect example of sublimation. You get dry ice and it goes from a solid and gases off into mist. It's, a perfect example of sublimation. We used to have my cousin in Pittsburgh, outside of Pittsburgh, had great Halloween parties, and he always had this thing out back with a big old cauldron full of dry ice, and it looked really neat for a Halloween party. So that's it on this here. Again, read the book. That's what all the questions are coming from. And this is a short video because this is a short chapter. And so in this module, we're going to have 2 chapters. So that's it for now.